Hey guys, so we're going to take a look at lesson 22, session 1. So that would be pages 505 through 508. Okay, so previously you learned about equations with one variable. In this lesson, we'll talk about equations with two variables. So let's try this problem. So Hiroku makes animals for her cousin. The instructions for making a fox say to crochet the stitches in a row and then join the ends to make a round. How can Hiroku use the round number to determine the number of stitches in that round? So I am going to make a table. So we're going to list the number of rounds and however many rounds for each, how many stitches are in each round. All right. So for one round, we know that we have 6 stitches. Right? Rounds 2 to 7 increase the number of stitches in the previous round by 6. So we're just going to add 6 for each round. So if we have 2 rounds, we have 12 stitches because we have 2 rounds, so 6 times 2 is 12. 3 rounds, we would have 18. 4 rounds, 6 times 4 is 24. 5 rounds, 5 times 6 is 30. 6 rounds, we would have 36 because 6 times 6 is 36. And for 7 rounds, 7 times 6 is 42. Okay, so the number in stitches in each round is 6 times the round number. So the number, and you can abbreviate too, of stitches in each round is 6 times the round number. So we could say that the number of stitches depends on how many rounds we do. Okay, so right, turn to the back. So how can Hiroku use the number of the round to determine the number of stitches in a round of her fox pattern? Explain how you know. So she can multiply the round number by 6. So we found the number of stitches in each round and saw the number of stitches is always 6 times the round number. Right, so in Hiroku's pattern, the number of stitches in a round depends on the round number. An equation in two variables is one way to represent the relationship between two quantities. The value of the dependent variable depends on the value of the independent. So dependent can stand alone. Or no, independent can stand on its own. If it's dependent, it depends on the other variable. So a store sells kits for making amigurumi animals. Each kit costs $15. The equation C equals 15 times K can be used to determine the total cost C of K amount of kits. In this situation, is C or K the dependent variable? So which one depends on the other? So 15 times K, whatever K is, so C depends on whatever K is. So dependent equals C, and the independent is going to be K. Okay. B, the equation K equals C over 15 can be used to find the number of kits K you can buy with C amount of dollars. In this situation, is C or K the dependent variable? So the dependent would be K. K depends on whatever C is. So whatever we plug in for C is independent, and K is going to depend on whatever we plug in for C. So independent is C. C, how are the equations in problems 2A and 2B alike? How are they different? So I'm going to start over here because it's kind of long. So both equations use K for the number of kits and C for the total cost of the kit. For the total cost of K amount of kits. I'm going to abbreviate equations as EQ. The equations both show the relationship between, I'm going to abbreviate, between K and C, but they do it in different ways. The equation in number 2A shows how to use K to find C. Multiply K by 15. In the equation in number 2B, so this one, K equals C over 15, shows how to use C to find K. And we would do that by dividing C by 15. We're at number 3. Reflect. Toroku and her cousins have $45 to spend on kits. Which equation do you think they would use to find the number of kits they can buy and why? So they have $45 to spend on kits. So I need to look for the one to see how many kits I need. So I need to know the number of kits. So the cost, so we know the total amount of money they have, divided by 15 should give me how many kits I have. Now, if it's a decimal, then we have to round down because we can't get a partial kit. So we would say K equals C over 15 because they know the value of C and they want to find the value of K. All right, go ahead and pause here, and I want you to try number 1 and 2 on your own on page 507. So you're going to put examples of a variable. So 6 examples of a variable. Come back and we'll try it together. All right. So think about what you know about variables, expressions, and equations. Fill in each box. Use words, numbers, and pictures. Show as many ideas as you can. So we know that expressions can have variables. And a variable is a what? It is an unknown number. So 3 times x, we can have n plus 5. We could have 2 times b minus 8. Does anybody remember what this is called? What property? Yep, it's the distributive property. Now, examples of variables we could say are x and b, because they're all unknown numbers. Right? We know that equations can have variables. Does anybody remember what the difference between an equation and an expression? Let's see if you can figure it out once I start writing. Yep, it's the equal sign. So we can actually solve it. We can't solve for this if we don't know what the total is. So on these, it gives us our total, so the difference is an equal sign. All right, what else do we know about a variable? We know that formulas have variables. So you could say area of a triangle equals 1/2 base times height. We know that one. We know volume equals length times width times height. Those are all variables. All right, we know that you can evaluate an expression with a variable. So evaluate, an example would be evaluate 10 plus 5 when n equals 6. So we would say n plus 5, and we're going to plug in 6 wherever we see n. So that would equal 6 plus 5. And we know 6 plus 5 is 11. All right, last example. You could solve an equation with a variable. So n plus 5 equals 18. You gotta look at my operation that I'm given and use the inverse operation, because my goal is to isolate my variable. I've got to put my variable in quarantine. So inverse operation, so the opposite of addition would be subtraction. I'm going to subtract 5. It's going to cancel out when I do on one side. Got to do the other. I'm left with n on this side. Bring down my equal sign. 8 minus 5 is 3. 1 minus 0 is 1. So I get n equals 13. Now box my answer. All right, number 2. Why can the value of the variable a in the expression a plus 2 be any number? Why does the variable b in the equation b plus 2 equal 5 have only one value? The expression a plus 2 tells you to add 2 to a. And you can add 2 to any number. So a can be any value. And then the equation b plus 2 equals 5 tells you that b plus 2 is equal to 5. The only number you can add to 2 to get 5 is 3. So b can only be 3. All right, let's go ahead and turn to the next page. So page 508. All right, go ahead and try this and then come back and we'll try it together. All right, number 3. There are 5 hidden treasures in level 1 of a smartphone game. Each of the other levels has one more hidden treasure than the previous level. How can you use the level number in the game to determine the number of hidden treasures in that level? Show your work. Oh, sorry, guys. All right, so let's make our little chart. So level and treasures. All right, so say level 1. So there are 5 hidden treasures in level 1. Easy enough. All right, and each of the other levels has one more hidden treasure than the previous level. So level 2, one more than 5 would be 6. Level 3, one more than 6 would be 7. 4, one more than 7 would be 8. Well, look what's happening there. Right, level 5, one more than 8 would be 9. So each number of treasures is 4 more than the level number. Right, so we could say just add 4 to the level number. Let's make sure that's true. So 1 plus 4 equals 5, 2 plus 4 equals 6, and 3 plus 4 equals 7. 4 plus 4 equals 8, and 5 plus 4 equals 9. So yes, it is true. So check your answer to problem 3A. So we could say level 1, 1 plus 4 equals 5. All we're doing is just writing down what we wrote before. So level 2, 2 plus 4 equals 6. Yep, that's true. Level 3, 3 plus 4 equals 7. Yep. Level 4, 4 plus 4 equals 8. Yep. And level 5, 5 plus 4 equals 9. So adding 4 to each level number gives the correct number of treasures. So yes, that would work. All right, and that's the end of session 1.